When we first learned about mass stoichiometry, I said we would come back to it. And here we are. Hello, darkness, my old friend. Solution stoichiometry. Now, we want to remember how the big picture in stoichiometry work, because that's going to be important, the whole big picture, not the details necessarily, but how we actually do stoichiometry. And we all started from some measurable thing that we knew, measurable known. Now, at the time when we were doing mass, that was always a mass. Always grams. Now, with solutions, it might be something different. We would turn that into a number of moles. We would take that number of moles and we would turn that into the moles of the thing we were looking for, the moles of unknown. And that was always a ratio step. And then we would take that moles of unknown and turn it back into some measurable, at the time, a mass, but some measurable thing or something that we can measure, some unit that we would use to measure that unknown. And stoichiometry is stoichiometry is stoichiometry. It's going to be the same big picture. Now, we're not going to work through this question, so if you're thinking to better write that down, you don't necessarily need to. What I want to do is I want to remind you what mass stoichiometry looked like, but this is mass, and you kind of already know how to do that. Just quick refresher. Now, what would happen is we would set it up like this, and again, I'm going to use what's called the factor label method, the single line, where everything is laid out there. And what happens is I've got the measurable known with a conversion factor to go to the moles of known, with another conversion factor to take it to the moles of unknown, another conversion factor to take it to the measurable of unknown. And more importantly, if I look at the units, I've got grams of sodium oxide on top and grams of sodium oxide at the bottom. They cancel out. I've got moles of sodium oxide on the top and the bottom. They cancel out. I've got moles of aluminum chloride on the top. Chloride on the top and the bottom. They will cancel out. The only unit I have left is my mass of unknown. Okay, in big picture terms, solution stoichiometry is going to be exactly the same thing. In the details, it's going to look a little bit different, and that's okay. The other thing I want to point out is with solutions, we can start to overlap masses and volumes of solutions, because now we have more things to measure. Anyway, circled the final answer, unit. Okay, so if I want to do unit conversion, just again remind you, because this is going to be the thing that we do. This is our focus in mass is look at the units. It's going to be our focus in solutions. If I have the molar mass of that sodium oxide, which I used in the previous one, is 62 grams per mole, what that means is 1 mole equals 62 grams for sodium oxide, and 62 grams, if I had 62 grams of sodium oxide, I would have 1 mole. They are the same thing. They are equal to each other. They are equivalent. The only difference is in one I'm measuring masses and the other one I'm measuring or counting numbers of moles. Okay, with solutions, I often use a concentration term, which is a volume and a number of moles per liter. Okay, so if I'm using that to convert from moles to grams, sorry, not moles to grams, moles to milliliters, or liters and liters to moles, I need that thing. But then, and the same thing as I got to finished saying. All right, that was a mess. For the reaction, here, it is exactly the same reaction, because we already know kind of how it looks. Now, obviously the answer is going to be different because I'm not doing a mass, and obviously I'm going to be working solutions into this. I'm going to start with mixing a solution with a solution. So I'm going to start with a volume, or I'm looking for a volume, and I have a volume. So I have 150 milliliters. I apologize, it's split over 2 lines. I want to do the same thing, that same pattern of thing I can measure to moles of one, to moles of the other, to back to thing I can measure. And that's going to be every single time. Stoichiometry always has those 3 steps. Okay, measurable from known to moles of known. I have a volume. To get moles out of a volume, I do volume times concentration. In this case, I have that 150 milliliters, but my my concentration is moles per liter, so the units have to work. So I convert the milliliters to liters, multiply by the concentration, and I get 105 moles of sodium oxide. If I go to the next step, the ratio is the same, because the atoms and molecules don't care if they are in solution form, solid form, or some other form. It doesn't matter. The ratio is the same. The reaction works the way the reaction works. And if I were to do that ratio, I would end up with 0.07 moles of aluminum chloride. And then I take that, and then what would that be if I wanted to know the volume of a particular solution? Well, volume is number of moles divided by concentration, which is that number of moles divided by the concentration that was given, and I'm left with a number of liters, you don't have to convert to milliliters. It's probably a little bit more familiar to you to have something like 280 milliliters rather than 0.28, but if you have the correct number with the correct unit that corresponds to that number, that's fine. Doesn't matter. Okay, I really like the factory label method, partly because it puts it all in one space, partly because I can analyze the units, and I'm going to be much more deliberate about paying attention to the units. And it would look like what's coming up, but again, I'm going to use that same thing where 0.7 moles per liter means that 1 liter of solution would contain 0.7, and 0.7 of that, 0.7 moles of that material would be found in 1 full liter of that solution. Okay, so in this case, it would look like that. Okay, so again, paying attention to the units. So liters of sodium oxide solution, I've got liters on top, liters on the bottom. Then I've got moles of sodium oxide on the top and the bottom. They cancel out. Then I've got moles of aluminum chloride on the top and on the bottom. They will cancel out. If I don't have one on the top and one on the bottom, they don't cancel out. But I'm left with, my only number there is, my only unit rather, is liters of aluminum oxide, and that, if I do the numbers, I end up with that answer, which we already knew. Okay, here's one where it's going to be much, much more likely that you'll see a combination of masses and volumes. So here, I'm asked to find a mass. So now I'm going to start with my measurable of known, which is a volume of solution. I'm going to convert that to moles, I'm going to convert it to moles of the other thing, and then I can convert that back to the measurable unit. Now I need to end up with a grams. So, just to kind of give us the basic information there, same information, but now it kind of keeps track of it. It's going to look like this. I couldn't figure out a way to make it come out one piece at a time, but I have my measurable known, which is my 560 milliliters, that gets converted to liters. I've got liters on top, that means I need liters on the bottom. That means moles is on top, so that my unit at the end of that first step, that first conversion factor, is moles. Moles on top, moles on the bottom, they will cancel out, leaving me with, in this case, moles of the other aluminum hydroxide. And then moles of that cancels with the moles of the same stuff on the bottom, where now I'm looking for a mass to be my last top unit so that it does not cancel out, and my final answer is in grams. Now, again, the whole point here is stoichiometry is going to follow the same basic pattern. The only thing that changes is the details of how it looks. But looks aren't the important thing. Units are the important thing. I'm going to let you try this one, and we'll take it up in class, see how it went. But for that reaction, again, similar to what we did before, so in terms of the overall pattern and placement of units and things like that, although we don't want to rely on that, it's going to look like what we had before. We've got 135 milliliters of a given solution where I know the concentration, and I'm looking for a mass of this chemical formula, so I know the molar mass. Okay, by the time we're done here, you should be good with kind of any version of stoichiometry that we've done so far. Volume and volume, volume mass, mass to volume, and I suppose I didn't include it, but that's from last time, mass and mass. I will say that these bottom two here, where you're going to volume, mass, mass, volume, those are going to be your most common ones that you're going to see from now on. It's going to be really, really rare that you do volume, volume, just because it's kind of boring to me. Anyway, talk to you another time.